So here we have the mass of the copper. This will be 0.265 kilograms. You have the mass of the aluminum being 0.145 kilograms. You have the mass of the water. This will be 0.825 kilograms. And we have the temperature initial for the copper. This is going to be 245 degrees Celsius. And we have the temperature initial for the water, equaling the temperature initial for the aluminum. And this will be 12 degrees Celsius. So we can say that the heat lost by copper is going to equal the heat gained by. So the heat lost by copper will be equal to the heat gained by aluminum and water. So we can say that the mass of the copper times the specific heat capacity of the copper times the difference between the initial temperature of the copper minus the equilibrium temperature. This will equal the mass of the aluminum times the specific heat capacity of the aluminum times the difference in temperature, so the equilibrium temperature minus TIAL. And this will be plus mass of the water. Let's say mass of H2O, specific heat of water, and then we'll say TEQ minus TI H2. So at this point, we can say that we can just plug everything in. So 0.265, 390 joules per kilogram per degree Celsius for the specific heat capacity of copper. And then we'll have 245 minus the equilibrium temperature. This is going to equal 0.145, the mass of the aluminum. The specific heat capacity of aluminum is 900 joules per kilogram per degree Celsius. And then this will be times the equilibrium temperature minus 12 plus 0.825, the mass of the water, times the specific heat, 4,186 joules per kilogram per degree Celsius. And this will be times the equilibrium temperature minus 12. Now you can use the solve function on TI-84, TI-85, or TI-89 in order to solve for the equilibrium temperature. And when we use the solve function, we can say that the equilibrium temperature is going to be equal to 18.5 degrees Celsius. So this will be our final answer. Again, you can simply use the solve feature in order on any TI-84, TI-85, TI-89 calculator and solve for the equilibrium temperature by plugging this equation in. You can say that T equilibrium could be considered X and then solve for X. So again, that final answer is 18.5 degrees Celsius. That's the end of the solution. Thank you for watching.